Hello viewers, welcome back to my channel. Today we will discuss about the flyweight design pattern. So again, the flyweight design pattern is a structural design pattern that lets you fit objects into given available RAM. Suppose we have multiple objects, but all the object has some common properties uh, or particles or variables which are being used constantly the same. So in that case, instead of assigning address for each object and the particle unique to the particle, we can do one thing. We can make this same particle uh, share the same space, RAM space. Okay. Let's take an example of game. Suppose we have a game and sometimes we faces that it crashes. This crashes because of space constraint, right? So what it has been doing, it is assigning address or space for each particle inside the game. Let's say we have a bullet, right? When we are firing a bullet in the game, there's a lot of particles of bullet particles of gun or maybe something like that which is being used constantly the same. It can be the case that speed is not same or coordinates is not same, but yeah, the particle is same. Like let's say we have multiple 10 to 15 users in the game, and both are firing the gun. Now the gun will be same, a bullet will be the same. So instead of assigning the variables or I mean the spaces for each gun, we can do one thing. We can share the spaces between them. So let's try to implement, and I will learn more in details. Right. So right. So let's have a flyweight design, a flyweight directory. In this, we will have particle attached. So the particle can have the parameters such as string image, then it will have coordinate x and y, and it can also have color, right? So okay, okay. So first of all, I have to assign this variable with I need to assign value with this variable. So let's have a constructor inside which we can have string image int x int y and color. This image is equal to image is x is equal to x. This y and this color color. Okay, fine. Now we can have another class which will be moving particle. Suppose the bullet is also a moving particle, right? So we, for all moving particle, we can have a same class, right? So let's have first of all include. Okay, Oh, sorry. Now we can have the same thing. Let's first make it public. We can have same thing such as int x, y, string, image, and color. Again, we will have constructor, and this time it will also take the same image x, y, and color. Okay, and let's copy it in here itself. Okay, cool. And after this, I can have one more class which will be nothing but particle factor. Here I will implement my logic. Particle factor. And this particle factor actually I will have my logic implementation. So first of all, let's have the particle itself. Yes. So I need to store this particle, right? For that, I need one storage. Uh, what would be? It will be map. Let's say map, and the map will take pair string. Oh, sorry, pair. It's again a string and particle. Since you know the string I have taken in pair, that means I am storing the image and color. That's it. Particle is undefined. Why so? Not defined. Okay, let's have one. Let's have one get particle, right? And it will be going to return my return particle itself. Get particle, and as I said, it should have the same parameter. Let's copy from here itself. Okay. And first of all, I implement my logic, which will be I will need to first check whether this particle has been already there or not. If it is not there, then I'm going to initialize this object. Otherwise, I'm not going to initialize. That's the logic here. So m dot find what image and color. If it is equal to m dot in, that means it is not there. Then I can just image and color initialize with new particle, and I'm just going to pass image X, Y, and color. That's it. What is inaccessible? Okay, 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 okay. Fine. Okay, so and from here I am going to return the particle itself, whether it is there or I've just initialized. I'm going to return from the map itself. And oh, that's good. So this is my implementation. It's basically first checking whether I have initialized that object or not. Suppose bullet. So Every time for every player, I'm not going to initialize bullet again. I'm not going to provide the space for each bullet. The bullet will be the same and it will have the same space. It's just that the coordinate will be different, speed will be different, but otherwise it will not be different. So I'm not going to initialize the bullet for each particle. If it is it been initialized, and I'll return from the map itself the bullet which has been initialized earlier. Otherwise, I'm not. So the main logic has been defined. Let's have one main class, main.cpp. Okay. Uh, First, let's include particle. Okay, and again we can have a moving particle. Okay, fine, and we can have one more particle factor. That's good. So let's define first of all a particle factor, because anyways we have to initialize map first, right? Then only I'm going to store object here. So particle factor pf. Now we can have particle itself. And, particle with part. Let's say we have bullet. X will be 10. That will be 20. And oh, sorry, what I meant. 10, 20, and the color will be let's say with black. Black. Okay, we can store the I mean uh, this object into in the particle, right? So pf dot get particle. Okay, uh, we should do one thing. Pf dot get particle. Inside that, we can just pass this parameter itself. If it is there, it will give me. Otherwise, it will initialize the object there itself. So we don't have to. I mean, we don't have to make particle again, right? So let's have this. Let's do one thing. I can just. That's it. Okay. So what is it will going to do? It will first check. Let's say we have another part two this time. So initially, I've initialized this bullet with black and color and bullet itself. Then again, I'm going to initializing, but it will not initialize. It will just return the bullet from the map itself. So that's is a logic which I have implemented, and this is a design pattern which it basically it does not give the spaces to each and every particle. It's tried to share the spaces between the particle which have the common properties, right? That's it. So I hope you enjoyed and like this video. So yeah, so see you next time.